was like, oh yeah, I've got to.
Alright, we are going to do log equations today. It is just one page, so hopefully it doesn't take that long. It's very similar to solving exponentials. Alright, so we've got a couple different methods. You have the same log base. So if you have the exact same log on either side, and that's all you've got, you can't have anything on the outside. Log 3, then you could cancel your log 3s
And you just set them equal.
and set them equal to each other.
That makes sense.
And then solve for x, so you would minus x, and you would get x equals -1. Okay, now there is something special you have to check for with logs, and it says in the directions right here, with logs, you have to check for extraneous solutions.
Everybody's least favorite thing in the world.
Yes. Alright, so checking for extraneous solutions is not as bad as you are going to think. What you need to do is you are going to go back to your original log. What's up?
How'd you get -1 on the first one? Sorry.
Subtract.
I thought you would have to divide the two.
Well, normally...
Okay, never mind, I understand. I just wanted to know.
You're good. Okay, so when you're checking for extraneous solutions, you are going to take your answer and you are going to plug it back into the inside log. Right, all I care about is the inside. So when I plug -1 into here, what's 2 times -1?
-2.
-2. If you get a negative inside, ooh, my voice cracked. If you get a negative inside, doesn't work. Not a solution.
So this is the solution.
Yep. So because x equals -1 is extraneous, the whole answer is no solution. And the reason why is because you can't take log of a negative number. You have that asymptote there, it's preventing you from going in the negative area. You can't take a log of a negative number, so if you get log of a negative, it's not going to work. Alright, let's try the next one. So, on this one, there's not a log on both sides. It's just by itself, and so this is where you're going to rewrite it in the other form. So if you can't cancel your logs, put it in the other form. So my base is an e, and then I'm going to go all the way to the other side. Squared equals x. And then a lot of times you get x by itself, and so that would be your answer.
And you just plug it back onto the x.
And so because this one here, on the inside of this log is just regular x, when I plug e squared in, is that positive or negative? Positive, right? E squared, is that a positive number?
Yeah.
Okay, so because it's positive, it works. All right, let's try another one. I'm actually going to kind of flip around. Go to 89. Because 89 is actually easier than the one I have in this box. All right, so the other method is having to use the properties. So on this one, I have 2 logs on this left side. All right, and so I can't go around the world if there's 2 separate logs. I've got to squish them together to make 1 log. So when I squish these guys together, what am I going to do with the x and the x minus 8? Multiply. So then, because you squish together the x and the x minus 8, and we're going to multiply those, so you can rewrite that as x squared minus 8x. And so now once you're to this step and you can't really do anything else because the x's are in the log and there's not a log on either side, this is when you're going to put it in the other form, and we're going to write it in exponential form. So what is my base? 3. What's going to what is the exponent going to be?
2.
2, because you're going to go all the way to the other side, equals
X squared minus 8.
x squared minus 8. X. All right, what is 3 squared? 9. Yep. So now it's a quadratic, and to solve a quadratic, you've got to move everything to one side. All right, and with quadratics, we are going to try to factor them. What multiplies to give you 9? Negative 9, but adds to give you negative 8. Negative 9 and 1. And so then when you solve those, you get positive 9 and negative 1.
So the
Do we have to put
negative
it again or
1 won't
anything?
work with the positive 9.
Yep.
Oh my god.
All right, so yes, with both your answers, you are going to come back up here to the original guy and plug them in. I don't actually care about what the number is. All I care about if it's positive or negative. Because if it's negative, it's not going to work.
So negative 1's not gonna work.
So when I go up here and I test 9 minus 8 is going to be a positive, so that one works. But when you test negative 1, that one doesn't work. So that's extraneous, but 9 works. So 9 is the only solution. All right, so those are your 3 methods. All right, so let's look at this other one in the box here, and let me show you why this one's a little bit more difficult. We're going to start it off the same way. We're going to squish it together. And we're going to multiply the x and the x plus 1 and get x squared plus x. All right, so you're going to multiply this guy and this guy together. And that's where I'm getting the x squared plus x. All right, once you get to this step here, we're kind of stuck. There's nothing else I can do except for go around the world, put it in exponential form. So this is base 10. So 10 squared equals x squared plus x. And 10 squared is 100. And then because it's a quadratic, we need to move everything to one side and set it equal to 0. All right, now the reason why this one is kind of bleh is because it's not factorable. Are there any 2 numbers that multiply to give you 100, but add to give you 1? No. So it's not factorable. What do you do?
No solution.
No.
You put a quadratic formula.
Quadratic formula. Or you can graph. Either way, it's gonna be on the calculator section.
Okay.
All right, so either way, it's gonna be on the calculator section. So, well, let me go to my screen here. So you can type in the entire quadratic formula into your calculator.
Oh.
Negative b plus or minus the square root b squared minus 4ac all over 2a. You type the whole quadratic formula in with your a, your b, and your c. And it will spit out your 2 answers. So my 2 answers on this one is going to be 9.512 and negative 10.512. So that's one of your options is quadratic formula. If you're like, ooh, I don't like the quadratic formula, I would rather graph it, then you could graph it. And on the graph, you can find your 2 zeros right here. So you would go second, trace, 0, left side, right side, enter. So negative 10.512, and then you would do the same thing over here, which would give you the 9.512. So they'd be on the calculator part, so if it's not factorable, that's what you do. Either graph it or do quadratic formula. Doesn't matter which one you do, they both will work every time. It's personal preference, but you gotta know how to do one of them. All right, and so then these are my answers here. So I've got 9.512 and negative 10.512. Now, which one of these guys is extraneous?
9.5.
Negative 10.
The negative 10.512, because when you put that back in here and here, you would get a negative in the log. Okay, let's try some other guys. So go to 84. All right, so on this one, both sides have exactly log 3 and nothing else. So we can cross them off and set the insides equal to each other. Now, if you were wanting to solve this, what would you do first? Subtract what? The x, yep. We're going to minus the x and add the 1. Are you okay with me doing it in one step? So you get 4x equals 8.
Divide by 4.
And then divide by 4. And x is 2. And then just don't forget to glance and make sure it's actually a solution. And it is. So we're good. All right, go to 85. All right, now on 85, there's not a log on either side. So I know I'm probably going to end up going around the world putting it in exponential form. But what do I have to do first? Divide by 2. We got to get rid of all of the things on the outside. You need to have just a log over there before you can put it in exponential form. So now that it's just a plain old log, now we can go around the world. So what is my base going to be? 5 to what exponent?
Squared.
Equals.
3x.
And then last step to get x by itself?
Divide by 3.
Divide by 3. So no, you're right. 25 divided by 3. Which on 8 point, you can write it as a fraction or a decimal. Doesn't matter. I'm going to leave it like that. When you plug it back into your log, are you positive?
Yes.
Yep, we're good. All right, let's go to 86. All right, on 86, what would you do first?
Subtract the 5.
Subtract 5. So you get 2 ln of x equals negative 1. And then?
Divide by 2.
Divided by 2. ln of x equals negative 1/2. Okay, and so then once you get your log by yourself, we're going to go in exponential form. So what's your base? E to the what?
Negative
Negative 1/2 equals?
x.
X. All right, now, on this one, if you have a negative 1/2, is that going to give you a negative number?
No.
No, negative exponents just turn it into a fraction. So we're good on this one. This one is not extraneous. So what a lot of people see is that negative exponent, and they're like, oh, it's negative. It's not. Negative exponents just make fractions. So this one's all good. And you could write it out like that, or you could type it in the calculator and get the decimal. All right, let's go to 90.
Cameron has a question.
What's up?
I was just gonna say, are those gonna be on the calculator or not? Or both?
Both. The ones that are on the non-calculator are, I think, like, you have nice numbers, like you're not gonna have to leave it in terms of E. If that, does that make sense?
Yeah.
So all of your non-calculator stuff will be a regular number as your answer.
So you're not gonna get like E to the
Right. Yeah. So if you have like E to the something, it'll be on the calculus part. Ooh, my pen. All right, so on this one here, first we are going to squish them together, and what are we going to do with the 5x and the x minus 1?
multiply.
Multiply, and so you're going to get 5x squared minus 5x. All right, and so then once you've squished it together and you get one single log, we can put it in the other form. So what is my base? 10 squared.
Equals 5x squared minus
What is 10 squared?
100.
And what am I going to do with that 100?
Subtract.
Yeah.
Make it
Make it a quadratic. Put it on the other side.
and take out a 5.
And take out a 5, because this one has a GCF. Which is actually, it's a good thing, because then you don't have to do the bottoms up. And then -5, +4 are the two numbers that multiply to give you -20, add to give you -1, which means x is going to equal 5 and -4. And then -4 won't work because when you plug it back in here, you would get decimal, or negatives, not decimals, sorry, negatives. So just 5, sorry, just 5 works. I guess, no, I do need to do both of them. All right, sorry. I'll do them quick though. I'll do them quick. All right, 487, when you squish this together, what do you do with the 3x plus 14 and the 5?
Multiply. Oh,
Divide because of the minus sign.
Never mind.
So that's why I wanted to do this one. Because this guy here is being divided. Now what happens with the log 6?
Cancel out.
They cancel. Yep, so multiply by 5, cross multiply however you like to think of it, but you're gonna lose the fraction. So we don't like fractions, so lose the fraction either by cross multiplying or multiplying by the denominator. And then what would you do?
Subtract the 14 and mine.
Subtract the 3.
I would subtract the 3. You could subtract the 14, you'll just do like an extra step. But I would subtract the 3 and get 7x, 10 minus 3. And then when you divide by 7, you get
2.
x equals 2. And does 2 work? Yes. When you plug it back into those guys with the x's, it works. Okay. Last one.
Oh.
All right, on 88. When I squish this together,
It's a foil.
I've got a foil. Yep. All right, now the other thing, the other problem I have here is this other side. I want this to just be an ln. So how can I lose the 2?
Divide.
But then I'd have a 1/2 over here, and I don't want that either. What's another way I can get rid of it?
You could do that.
Yeah, move it to the exponent. All right, so I'm going to push it back out to the exponent, so I have an ln, and that's it on both sides. And then you can cross off your ln's. This guy right here, you are going to have to FOIL, so don't forget to do that step. 3x squared minus 3x minus 2x plus 2. And then over here, I'd have an x squared. Because you have a squared, we do need to move everything to one side. So 2x squared minus 5x plus 2. All right, so 3 minus 1 is 2. I combined those guys and got -5, and then the 2 just dropped down. Yeah, so this is a bottoms up. All right, so 2 times 2 is 4. What multiplies to give you 4, but adds to give you -5?
X minus 4.
Uh-huh. And we have to go back and divide by
2.
2. So really, I'm going to get x minus 2 and 2x minus 1. All right, because 4 divided by 2 is 2, and then bottoms up this guy, which means my two answers are 2 and 1/2. Which one's extraneous? The 1/2. And when you plug 1/2 back in.
Always gonna be extraneous.
Not always, but a lot of times. Like I hesitate to say, yes, always, but a lot of times one will be. All right. That is it. I don't think there's any mistakes on your homework, so you are good to go. Last homework, and then you got a homework quiz tomorrow.